This presentation focuses on the association between obesity and BMI, specifically the consumption of sugar-sweetened beverages, BMI, and how it leads to obesity. A study conducted by Kaplan et al. Demonstrated that newly arrived Hispanic immigrants are generally healthier than U.S.-born Hispanic population. However, these trends disappear over the years as immigrants adapt to the new environment and the social cultural environment. The results of the study demonstrated that the prevalence of obesity among foreign-born Hispanic increased based on the number of years spent in the U.S. Those living in the U.S. from 0 to 4 years had a prevalence rate of 9.4%, while the prevalence for those living in the U.S. for more than 15 years increased to 24.2%. Obesity among Hispanic also tends to affect women more than men. In a study by Benan et al., 71.7% of Hispanic working in the manufacturing industry have higher obesity prevalence due to the shorter hours of sleep, demonstrating that employment also affects obesity prevalence. There are many factors that may influence the obesity prevalence among minorities, such as race, ethnicity, socioeconomic status, culture, genetics, and environment. In order to find the appropriate prevention program to decrease or minimize the prevalence rate among the Hispanic population, we must consider these different factors. An appropriately developed program can be very effective as long as all factors are carefully analyzed and considered. To better understand these relationships between several risk factors and obesity, data from the BFRSS was assessed and analyzed. The objective of this project is to determine if there is an association between the consumption of sugar-sweetened beverages and BMI, and to determine how minorities are affected and how obesity plays a role. The information gathered from this study will be used to formulate an intervention program to decrease the prevalence of obesity among different groups. The data set used to assess the association between BMI and sugar-sweetened beverages consumption within the state of New York was obtained from the Behavioral Risk Factor Surveillance System. This is a collaborative system between the United States and the CDC. The Behavioral Risk Factor Surveillance System provides data on risk behaviors, chronic health conditions, and the use of primitive services through adult population older than 18 years old living in the U.S., collected through ongoing health-related telephone surveys. Different factors assessed by the BRFSS include but are not limited to health status, healthcare access, exercise, chronic health, oral health, tobacco use, alcohol consumption, and much more. Since our target data focuses on the state of New York, the data obtained from BRFSS was restricted to this state. Several demographic variables were selected as covariates for this analysis, which may increase the risk of obesity and can be common confounders and affect the overall outcome. The variables in the data were obtained and combined into variables that could be easily evaluated. For our methods section, since the data contain a vast amount of information collected from all 50 states, and our main focus was only the state of New York, the data had to be cleaned out. First, we restricted all data to the state of New York as mentioned, and then set the necessary variables and parameters. The BMI section contained different BMI measurements. They were condensed into 3 different variables. The sugar-sweetened information was also transformed from 2 variables down to 1 in order to assess the association. The monthly and sugar-sweetened beverages consumed was converted to a weekly consumption. The combined variable conversion resulted in a new variable, the sub-weekly, which is our target variable. The race variable was condensed into white, black, and African American and other in an effort to have enough statistical power and be able to see a significant difference between the group. The education variable was also condensed into 2 different categories. Since income is a categorical variable, the 5 different variables were combined into 3 different categories to simplify the variables and generate a varied distribution. Status C15 was used to process and analyze the data. Once all variables had been reorganized, relabeled, and transformed, a final analysis was generated to exclude any missing variables generated with the creation of new variables. A final summary analysis was generated to determine that all observations continued to match the original observation number of the data for the state of New York. Once the data had been cleaned up and appropriate variables had been identified, several regression models were generated using weighted variables. In addition, the variables were examined to verify and validate the assumption of linear regression. Since our outcome, BMI, is a continuous variable, linear regression must be used to verify the assumptions. As we can see from the results, we have two different tables. We produced two different tables. Table 1, which is statistical summary. The table provides a summary of the data analysis that assesses the association of sugar student consumption and BMI in the state of New York. As indicated in the table, the percent BMI in the obese population is higher when the number of weekly sugar student beverages drinks is more than 7 per week. The BMI is at 21% in the obese population, while the normal BMI is at 18% for the same number of drinks. In addition, the BMI percentage greatly increases among those who have a high school degree or less. The percentage is at 43, while the normal BMI among the same group is at 36. And as we can see, the percentage also changes both, like I mentioned, down one group of the obesity level and then across. So the obesity, even if they're the obese or considered obese, not overweight, high school degree population is higher percentage than the college graduate. But of course, if you're looking by section in terms of high school degree, some college or college degree, and compare between overweight and obese, then the obese is higher in comparison, which makes perfect sense as to what that would be. Another observation is the percentage increase among those with cardiovascular disease in the obese population. The AMI percentage trend increases from 9% among the normal BMI to 11% among the obese population. These are the people that have been diagnosed with cardiovascular disease in comparison from a normal BMI to an obese BMI. Table 2 focuses on the linear regression, the true assumption, and then the 95% confidence interval and the p-values, reaffirming the association between the variables. In conclusion, there is an association between the consumption of sugar-sweetened beverage and BMI, resulting in an increase in obesity. This reinforcement is the association presented in the conceptual model of obesity and other risk factors. As we can see from the model here, we have BMI, health-related quality of life, mental health, physical activity, and then obesity, which obesity is affected by all different factors. And we can see that BMI has a strong association between quality of life, which then associates with obesity. So anything that we do within our regular lifestyle affects our BMI, and if our BMI is affected, there are other factors that are affected as well. In addition, the minority groups are affected significantly in comparison to the white population. This information provides significant insight into the type of intervention program to decrease the overall obesity prevalence. Some ideas for a research intervention are early intervention program, community involvement, also known as a CBPR project, policy development, such as taxation on sugar drinks, as the state of California has done, or cutting back on the type of food that is offered as institutions, community intervention, health education for family, children, or adults, depending on the exact target population, and then hospitals involvement, clinical involvement, having the care providers give the right information, accurate information, inform patients of what they are doing wrong in order to have an unhealthy lifestyle that might lead to a higher BMI, which could lead to other consequences. And then we also need to take into consideration our built environment. And while we're developing an intervention program, we need to be culture sensitive and maintain cultural humility, which are very, very important aspects of an intervention program. I believe that the best intervention program for this would be health education, teaching people what it is to have a higher BMI, what leads to obesity, and helping them understand what they can do if they are already at that stage. And with health education, you can involve community members and have them develop the program, have them initiate the process so that they meet their own requirements and their own needs. So the ideal intervention program, in my opinion, would be developing a participatory community-based research project where you have the opinion from different members of the community and involve stakeholders in order to develop an effective educational program while maintaining cultural sensitivity and cultural humility. If you are able to have the involvement with other community, the intervention program might be that much more successful. People will feel empowered and committed to their own programs. I think, like I said, health education regarding obesity, BMI, lack of exercise, and all those other risk factors, I believe, would be the most effective intervention program. As we conclude and we talk about the association, we can tell from our data that there is a high association between sugar consumption, BMI, and obesity. And I think it's very important to address the issues within the community. And this is done through health education, assessing the built environment, and educating the community in general. Thank you for listening.